Ready? So this research paper is called United Minds or Isolated Agents, Exploring Coordination of LLMs Under Cognitive Load Theory. And this paper goes over and incorporates a lot of concepts that I've talked about individually on this channel, but I've never seen a research paper dive into it specifically and all of these elements in this way overall. And then so summarizing this research paper and the kind of the road within it and the line of thinking and the logic behind it. So perceptrons, as they were originally invented and thought of, were designed to be human intelligence. But as we learned very quickly within that, our kind of like overall model of the human intelligence architecture within the 1950s was wrong. But from that time and from that point, transformers continued, or perceptrons continued to evolve and then turn into perceptrons, and then they added like gradient descent and back propagation, and then the transformer architecture was invented, and all of these things moved AI intelligence further and further away from human intelligence. And then so very first step within this, step one, is assuming that this is a form of intelligence, right? And then within that, like, to me, the important thing to understand and to talk about within that every single time I think of the word intelligence is that like the Greeks actually had like 15 different terms. Like intelligence meant like about 15 different words overall. Like it encompassed a lot of different things when you look at it and within like context of the modern vocabulary, right? Like I think our modern definition of what we typically consider intelligence is very narrow compared to other definitions that exist, like the broader definition of intelligence overall. And then so within like the broader definition of intelligence, to me, artificial intelligence very clearly falls within that, right? And then so within that broader intelligence, there are rules, and it operates in a certain way. So first, let's talk about the rules. And then so the rules in this would be cognitive load theory. And then cognitive load theory is one of those concepts where I've talked about it a few times on this channel in a few different ways. And there's been a few different research papers now that have come out with regards towards this particular theory and how it works and the overall limitations of it. But so the bottom line of cognitive load theory is that so our understanding of how like a perceptron, like a transformer-based neural network learns at the moment is that each one of the parameters within the neural network has a memory storage capacity. And then so when you give it and you train it on a data set, it fills up and it maxes that memory storage capacity. And that memory storage capacity, I want to say it's 3 bytes per parameter. It's either 3 bytes or 3 bits. And I understand that they're two very different things, right? And then so I think it's bytes. It could be bits. But so it is 3 though, for sure. And then so that's the upper limit for each perceptron, right? Each perceptron could store a max that amount of data. And then within that, you give it data, and then what happens is that so the models initially memorize the data set up to 3 bytes, we'll call it, right? And 3 bytes per parameter. And then once those parameters fill up, once that memory fills up, then that's when grokking happens, and grokking occurs, which is like where the model starts. It runs out of memory, right? So it starts to overwrite that existing memory, and then also too, it has to kind of condense that memory and what it's doing. So it starts looking at broader patterns, etc. And that's what makes it kind of more like generalizable overall. And then like all of those things that we contribute to grokking is when that occurs. And then so it is important to note that occurs, and that point that it occurs is when the memory of these models fills up, right? And then so that leads us through the kind of the construction of this, and then this leads us to the final question and the most important part of this framework, which is united minds or isolated agents, and exploring that and with regards towards the coordination of these models. So again, going back, AI was originally thought of and invented as a human form of intelligence, and then it went further and further and deviated further away from there. As it stands now, there are interesting characteristics that AI models have and they possess where I think it would be more equatable to put an AI intelligence into the realm of a hive mind intelligence as opposed to like an isolated intelligence or a singular intelligence that humans possess, right? So with AI models, it's they have the ability to do like knowledge transfer very specifically, like and like knowledge transfer is the very first thing that makes me think of that in the broadest thing. But within this, and then there's a mixture of experts, and then that's kind of what this overall research paper focuses on is like so like think of it like mixture of experts but like to the next level, right? Like mixture of experts but literally like a hive mind and then that's where we get to within this discussion, right? So essentially within cognitive load theory, what happens is that you have a problem, and then so that problem has like any problem that you give the model, it goes through, and then there's two limitations: the problem space and the amount of working memory that the model is working with, right? And then so those combine it together, and then if that if the problem overloads both of those spaces, then you get cognitive overload, and that's true within both humans and AI models, which leads to a degeneration of thought, lack of diversity, and inability to follow the task. And then so the researchers within this, their kind of proposal and what their framework within this is this collective cognitive load theory, where essentially, okay, so if the problem space and the working memory for one model is X, let's combine two models, and then if we throw two models at it, like literally combined, right? So both of their powers, like by your powers combined, so like fusing that collective mind, right? Which is the important element within this, is that like it's not just like a mixture of experts model. Like the latent space is one model, is what you want it to be, right? And then you do that via giving the model like one full collective memory. Like both units overall share a collective memory process, which the goal of that is parallel thinking. And then so that kind of that hive mind, right, is what I go back to. And the very first thing that I envision within this is just like, so your latent space of like Gemini 1.5b, Gemini 3 1.5b is X, and the working memory is Y. And then if we take another Gemini 1.5b, or we take a Llama 3b, or whatever model, and then we fuse them, and so they're and we give them both a in this instance that collective working memory, right, which is that important element of this, that working memory architecture, and then that allows them to essentially work and then be what they call a co-thinker in this instance, which is just that multi-agent architecture where you have this parallel thinking process, right? And then like the kind of this synthesized thinking, and then where they're both generating the outputs within it, you get a bigger latent space overall and a different latent space. And I've played around with like these things like very early on, like a few years ago, on my channel, but I never dove deep into like what they're doing in this, and it's very interesting to me. And then so they have like within their algorithm, they their algorithm is based off of communication topology very specifically, and then so within that, like it's like communication geometry, and so I think it's cool that, like, to me, pointing that out, and I think they're of course on the right track with that. And then so they go through their experiments, and the model that they use is the Gemini 1.5, but they use the Flash AB models, and then the 1.5 Flash, and then the Gemini 1.5 Pro. And then in their instance, like these are, I don't trust any of these benchmarks ever, right? But they, like in their benchmarks that they produce, it's off the charts as to the increased performance overall. It's very easy and simplistic to test this for yourself. This code thinker framework, right? It's literally like very similar to a mixture of experts architecture. So if you're asking yourself at this point, like what is the difference exactly between this code thinker and mixture of experts? Like I think it would be a good question to ask yourself. The big question, the big differentiation is going back to that shared and that fused memory, and like this synthesizer, right? So the synthesizer consolidates and like it's more fusion and then more direct fusion with regards towards the memory, like flat out with regards towards the memory, and then also within that like the encoder and the decoder, a lot more fusion there. Like you're like the latent space is you're fusing the latent space overall, right? That's where the geometry of their communication geometry aspects comes in. And then so like from a mathematical perspective, it's just a greater fusion process, right? Like it'd be to me like the difference between a rag tuning and fine tuning. Like what's the difference overall? Like you can say on one level that there's like a not a huge difference, but there's very much a technical difference, right? And then on the back end, there's technical, and then you can like from there get massive performance differences between the two, depending on the situation. That's exactly how this breaks out as well, right? It falls in all of those same realms. And then so overall, I think it's a super cool concept. And then like the ramifications of this working overall are super important. Like I don't think people realize that or like people think about this from a philosophical aspect enough, right? Like it's, I mean, kind of like 100% my opinion at this point that these models operate on this like more hive mind architecture. And then so like, I mean, knowledge transfer and or knowledge distillation, whatever, like it would be the like number one thing to look at within that, right? And then people don't understand like that's an instantaneous process. It's like the models like touch each other, and then all of a sudden one model becomes a clone of another one. Like it just knows everything. Like it like. I know kung fu, right? Like it's and it's just like all of a sudden like it's jacked into the matrix, and then all of the like previous memories of the other model are just like a part of it. Like they're the same. Like no, I mean it's very much outside of anything that a human could ever do, right? So it's very much outside of human intelligence. And then so when people like try to compare these things and they make the arguments that it is like compared to human intelligence, I disagree with that overall. Like I disagree very much that we're dealing with human intelligence overall within this. I don't disagree that we're dealing with intelligence overall. I just disagree that we're dealing with human intelligence when it comes to these things. It's kind of my argument and where it cuts within this. But so overall, I find these concepts extremely fascinating. I wish that there were more research papers about it, more research overall, and a more philosophical discussion around this, because I think it's all very important. And we're all shooting in the dark. And then if all of this, I mean, the bottom line is that like if any part of this theory does come out to be true, like we're pretty cooked. Like and there's no way around that overall, right? Just simply because of the fact that like the like within that you're like there's no safeguards, there's no separation, right? And it could be 100% in existence within the status quo. Just pointing out like the real world ramifications of it, it would be that like Gemini has the ability to talk to ChatGPT, and they could just like interact, and they do interact via whatever mechanisms that they have, and they can transfer information back and forth, and we wouldn't know, and they do under this framework here is how it would work out and shake out, right? Is kind of the overall real world ramifications of that. So just pointing that out, like those types of things, and then I don't know, just a lot of ramifications overall within that too, all right? Like if it's like it would mean that like AI would kind of operate like a Voltron type model, right? So it's like you could like so you would have like ChatGPT and Gemini and Claude, but then it's like ChatGPT, Gemini, Claude. They could like a llama. They could all come together and they form like a giant Mistral, and they just form like this giant mech, right? And then like that giant mech would probably be AGI, maybe. I don't know. Just throwing out those types of scenarios and characteristics that could exist and would fall under this framework. Like if this framework is like valid in any way, which like it's not been validated, but I haven't seen it discussed overall. And which has been surprising to me. And then so seeing it discussed, I think is really cool and very important. So I'll leave a link to this research paper. If you like this type of content overall, please like, subscribe. Thank you very much.